Hello everyone, I am Dr. Jyoti Pillai, Professor CSVTU Bhilai. Today we are going to discuss on the topic stack. Stack is an important data structure. Stack is a dynamic, linear, non-primitive type of data structure. A stack is a first in last out system or last in first out system, which is a type of list in which items may be inserted or removed from only one end, that is the top of the stack. A stack may be used in our daily life. For example, a stack of dishes. Dishes may be added or removed only from one end of the stack, that is from the top of the stack. The plate which is at the top of the stack will be removed first, and the plate which has been there for the longest period of time will be taken out at the last position, that is it will be at the bottommost position of the stack. The main stack operations which can be performed are push operation and pop operation. Push, pushing or inserting an item into the stack. Pop, removing or deleting an item from the stack. The restriction in the stack is that items can be inserted or deleted only from top of the stack. Push operation is a process in which the item is inserted at the top position, or it will be included or inserted at the top position. We can see from this example that we have got two elements and the top is pointing to the top element, and if a new element 10 has to be inserted, first of all the top position has to be incremented, and then at the new top position the item 10 will be inserted. Then like any other data structure, in stack also we have to check for the overflow condition. Overflow condition arises when the stack is full, there is no memory space left, and still the user is trying to insert an item into the stack. Okay. So, the first we will be checking whether the stack is full or not, and if the stack is found to be full, then overflow condition arises and the operation is executed. Else if the stack is not full, some space is still left, then item will be inserted. For that, first top will be incremented by 1 and then item is inserted at the top position. The next main operation of stack is pop. Pop, that is accessing the content while removing the item from the top of the stack, and that is popping out the topmost element of the stack and then accessing that element. For example, if we have got 3 elements, and when pop operation is performed, the top element will be removed from the stack and top will be decremented by 1. Similarly, in pop operation, as we have done in the push operation, we have to check for the error condition. If a stack is empty and if you are trying to remove an element from the stack, then an underflow condition arises. So, first of all we have to check whether the stack is empty or not. If the stack is not empty, then we will be popping out the top element from the stack and will use the top element of the stack, and then top will be decremented by 1. The next stack operations, that is auxiliary stack operations, are peek operation, is full operation and is empty operation. Auxiliary stack operations performed on stack are peek, is full and is empty. Peek is used to get the top element or data element of the stack without removing the top element. That is, when peek operation is performed on the stack, the topmost element will be returned and the value within that element can be accessed. Next operation is full. Is full is to check whether the stack is full or not. Max size is the maximum size, for example, allocated to the stack. For checking whether the stack is full or not, top is checked with the max size. So, is full function will be checking whether the top is equal to max size or not. If top is equal to max size, then return true, else return false. Is empty is checked, is used to check whether the stack is empty or not. That is, stack will be empty if there are no elements present within the stack. So, is empty when used will be returning a true value if stack is empty, and will return false value if stack is not empty. That is, if top is not equal to -1, because the top value starts with, the pointer starts with 0. So, if top is equal to -1, it will be returning true, indicating that the stack is empty, else it will return false. There are various applications of stack, where stack plays an important role in direct applications. For example, in balancing of symbols, infix to postfix conversion, evaluation of postfix expression, implementing function calls including recursion, finding of spans, finding spans in stock markets, which is referred to as in the problem section, page visited history in the web browser, undo sequence in a text editor, matching tags in HTML and XML. There are some indirect applications of stack also in auxiliary data structure for other algorithms. For example, in tree traversal algorithms, stack can be used to traverse each of the nodes of the tree. Components of other data structures, for example, simulating queues is an application of stack. Let us discuss about the first application of string, that is reversing a string using stack. For that, first of all, a string is inputted and a stack is used for reversing the string. So, when a string is inputted, string is read character by character from left to right. Read the character from the string is the first operation to be performed, push that character into the stack. This reading and pushing the character into the stack will be done until the last character of the string has been read. After that, the second part of the process is to reverse the string. For that, we will be going on popping out the top element from the stack, that is the topmost character will be popped out, okay, and will be printed to the string. One by one, the top element from the stack will be popped out and will be assigned to the string until the stack is empty. For example, let us take a string spot. Then we will be using a stack. In the first part of the procedure of reversing the string, we will be reading character by character. S is the first character, that character of the string will be read and will be pushed into the stack. The next character P will be read and will be pushed on top of S. O will be read and will be pushed on top of P. Finally, T will be read, that will be the end of the string, that last character will be read and will be pushed into the stack. Now, the second part, for reversing the string, we will be using that same stack, popping the top element from the stack and assigning it to the string. T will be popped out and will be assigned to the string, then O will be popped out and will be assigned to the string, P will be popped out and will be assigned to the string, and finally, S will be popped out and will be assigned to the string. So, the process will be continued until the stack is empty. That means, reverse string is tops. We know that there are three notations for expressions: infix notation, prefix notation and postfix notation. In any arithmetic expression or mathematical expression, operands and operators are used. Operands are the basic objects on which operation is to be performed. Operators are used to indicate that what operation is to be performed on which set of operands. In infix expression, the operator is present in between two operands. For example, A plus B, where A and B are the operands and plus is the operator. Operator is present in between A and B. For evaluating the arithmetic expression, particularly the infix expression, Bodmer's rule is followed, where precedence is given to each of the operators. The first precedence is given to parentheses, braces and brackets. Second precedence, second importance is given to the exponential. Third is given to asterisks and forward slash which is used for multiplication and division, and it is read from left to right as both are having the same precedence rule. Whichever is coming first from left side will be operated upon first. Second and the fourth precedence is given to plus and minus, that is addition and subtraction, and out of these two whichever is coming from left to right first will be executed first. Prefix or Polish notation, as the name indicates, the operator will be present before the operands. Operator, then the operands will be present. In postfix or reverse Polish notation, the operator is present after the operands. Okay. Post means after the operands the operator will be present. So, that is why the name is given as postfix notation. Let us see another application of stack, where stack can be used to convert infix to postfix expression. So, here the input is the infix expression and the output which will be generated using stack processing is the postfix expression. That is, stack is used as a media for converting infix to postfix expression. So, in the algorithm part of the process, first scan the input string, that is the infix notation of the expression from left to right. If the next symbol scanned is an operator, pop and append to the postfix string every operator in such a way that the operator which is scanned, all the operators above the left parenthesis will be popped out and added to the string. And if the new operator is having lower precedence than the operator which has been scanned, that is, the operator has got higher precedence or equal precedence that of the new operator, then pop out the operators and add it to the string. Push the new operator into the stack. When left parenthesis is seen or encountered, it must be pushed into the stack. When a right parenthesis is encountered, all the operators down to the most recently scanned left parenthesis must be popped out and appended to the postfix string, and that pair of parentheses must be discarded. When the infix string is completely scanned, that is, till we have reached the last operator, the stack may still contain some of the operators. So, all the remaining operators should be popped out and added to the postfix string. Let us discuss this input expression with an example: a plus b asterisk c slash d minus e. Here we will be reading the characters from left to right. The first character encountered is an operand, so it will be added to the postfix string. Next symbol scanned is plus, it is an operator, it will be pushed into the stack. B is an operand, it will be added to the postfix string. Asterisk is an operand which is having higher precedence than plus, so it will be pushed into the stack. Now, C, the next symbol will be added to the postfix string. The next symbol scanned is forward slash, that is the division operator. This division operator has got the same precedence as the multiplication operator asterisk, which is already present in the stack. So, asterisk will be popped out and will be assigned to the postfix string, and forward slash will be pushed into the stack. Now, when D is encountered, as it is an operand, it will be added to the postfix string. The symbol scanned is minus. Minus is checked with the forward slash. Since forward slash is having higher priority as compared to minus, it will be popped out and will be added to the postfix string. Now, the next symbol present at the top of the stack, that is plus, is having the equal precedence as compared to minus. So, plus also will be popped out and added to the postfix string, and then minus will be pushed into the stack. The next symbol encountered is E. E is an operand, so it will be added to the postfix string. The next operator will be checking the next symbol. There is no symbol left in the expression. So, now we will be checking the stack. We will be popping out all the operators from the stack as we have discussed in the algorithm one by one from top of the stack. Only one element is or only one operator is left in the stack, that will be popped out and added to the string, resulting in final postfix expression as A, B, C multiplication, D division plus E minus. Let us take another input expression, infix expression, which is expressed in infix notation, left parenthesis A plus B asterisk, left parenthesis C minus D, right parenthesis forward slash E. Now, using stack we will be converting this expression into postfix. The same procedure will be applied here also. We will be reading the characters one by one from the left position. The first symbol which is encountered is left parenthesis. So, that will be added or pushed into the stack. After that, the next symbol is A. A is an operand, it will be added to the postfix string. Plus is an operator, it will be pushed into the stack. Then B, B is added to the postfix string. Next symbol encountered is asterisk, it will be pushed into the stack as it is having higher precedence as compared to the top element plus. Then left parenthesis, when left parenthesis is encountered, it is pushed into the stack. Then next symbol scanned is C, it will be added to the postfix string. Next is minus, minus is inputted into the stack. After that D, D is an operand, it will be added to the postfix string. The elements which are popped out from the stack, those elements will be added to the postfix string, that is minus will be added to the postfix string or postfix expression. The next symbol encountered again is right parenthesis. So, asterisk will be popped out first and will be added to the postfix string, plus will be popped out and will be added to the postfix string, and then as soon as left parenthesis is found in the stack, both left and right parenthesis will be discarded. Now, again scanning the infix expression, the symbol scanned is E. Before E, there is one more symbol, that is forward slash. Forward slash will be pushed into the stack, which is used for the division purpose. Slash will be pushed into the stack. Then the next is E. E is an operand, so it will be added to the expression, postfix expression. Now, we have reached to the end of the infix string. So, now we will be checking the stack. Stack has got one operator left. So, that operator will be popped out and will be added to the postfix string. So, the final postfix expression which we have got is A, B, C, D minus asterisk plus E slash. Similarly, another example can be taken. Okay. Using the stack, we can perform the infix to postfix conversion. One more very important application of stack is evaluation of the postfix expression. If a postfix expression is given, using the stack we can evaluate the postfix expression. While reading the expression from left to right, if the element is an operand, we will be pushing that into the stack. If the element is an operator, pop the two operands from the stack and then evaluate it. Push back the result of the evaluation. Repeat it till we have reached the end of the expression. Again, if we are going into the detail of the steps of pushing and popping process, first add a right parenthesis to the postfix expression. Read the postfix expression from left to right until a right parenthesis is encountered. if reading from left to right, if an operand is encountered, push it into the stack. If an operator is encountered, pop 2 elements from the stack. The topmost element will be A, the next to top element will be represented if for example by B. Evaluate B operator A and then push the result of B operator A into the stack. Okay. Then finally, any variable result will be equal to the pop element, that is the topmost element, which is the single element which is left in the stack will be popped out and will be put into the result. So, the expression will be scanned until a right parenthesis is encountered, and whenever an operator is popped out, we will be performing the step 4 repeatedly until right parenthesis encountered. Okay. Finally, if you are left with a single element in the stack, and that element will be popped out and will be assigned to the result variable. Let us see with an example here. The example expression, which is a postfix expression 4, 5, 6 asterisk plus. The symbol scanned first is 4, it will be pushed into the stack. 5 is an operand, it will be pushed into the stack. Now, 5 is the top element. Next, 6 will be pushed into the stack as it is an operand. So, it will be pushed into the stack and 6 will be the new topmost element of the stack. The next symbol scanned is asterisk, which is an operator. So, whenever an operator is encountered, then top 2 elements will be popped out. First 6 will be popped out, which is represented by A, then 5 will be popped out. 6 into 5 is 30, that is where the operator which has been encountered will be operated upon in the top 2 elements which have been popped out. So, 5 into 6 is 30, 30 will be pushed back into the stack. Now, the 2 remaining elements in the stack are 4 and 30, 30 being the new top element of the stack. Now, the last symbol scanned is plus, which is an operator, and whenever an operator is encountered, pop out the top 2 elements. So, 4 and 30 will be popped out and plus will be used for performing the addition operation with 4 and 30. Result is 34, 34 will be pushed back into the stack. Now, when we scan the expression, we see that that is the last character of the expression. So, final result will be 34. So, we have seen that how postfix expression can be evaluated by using the stack. Using stack, we can convert infix to prefix expression also. For that, first we have to reverse the infix expression. Whichever infix expression is given, that expression has to be reversed. Scan the expression again from left to right. Whenever the operands arrive, print them or add to the prefix string or prefix expression. If operator arrives and stack is found to be empty, then push the operator into the stack. If the incoming operator has higher precedence than the top of the stack, push the operator into the stack. If incoming operator has got same precedence with the top of the stack, then push the operator into the stack. If the incoming operator has lower precedence than the top of the stack, then pop the elements from the top of the stack. When end of the expression is reached, pop and print all the operators from top of the stack. If operator is a forward slash, then push it into the stack. If operator is left parenthesis, then pop all operators from the stack till it finds a right parenthesis or opening bracket in the stack. If operator is right parenthesis, then push it into the stack. If operator is left parenthesis, then pop all the characters from the stack till it finds a right parenthesis. If top of the stack is right parenthesis, push the operator into the stack. At the end, reverse the output, giving the final postfix expression. The same can be explained stepwise. That means, first of all we have to reverse the string, then scan from left to right and follow the procedure. Then at the end, whatever result has been obtained, you have to reverse that expression to get the final postfix expression. Till now we have seen the discussion about the stack using arrays. Now let us see the linked list implementation of the stack. Instead of using array, linked list can also be used to implement a stack. Linked list allocates the memory for the stack dynamically. Time complexity in both the scenario is the same for all the operations which have to be performed, that is push, pop and peek. In linked list implementation of the stacks, the nodes are maintained non-contiguously in the memory. Each node contains a pointer to the immediate successor node in the stack. Stack is said to be overflow if there is no space left in the memory, and the stack is considered to be null if there are no elements present, not a single memory space has been taken up by the elements. The same procedure for adding a node to the stack is called as push operation, and when it is implemented using the stack, using the linked list, then in that case a new node will be created, and then the element which has to be inserted will be added to the data part of the new node, and the new node will be added as the head of the linked list. And if the linked list is empty, the new node will be the single node present in the linked list. So, here we can see from the example that we have got 3 elements. The top pointer variable is consisting of the address of the topmost element 4800. 4800 is the address of the topmost element. Now, when a new element is to be inserted, then top will be assigned the address part of the new element, that is 4700, and 44 is the new element which is to be added. So, that will be added in the data part of the new node, and new node will be added to the top of the stack. Similarly, when we see the deleting of a node from the stack, pop operation is performed. In that case, the node which is to be deleted will be deleted from the top position, that is the head of the linked list or the starting node of the linked list will be containing the top of the stack, and head or start variable will be containing the address of the topmost element. So, element which will be popped out will be deleted from the head position of the linked list, and then head will be reinitialized to the next of the head position of the stack. Okay. Same thing can be seen from an example that the original linked list is having 4 nodes. The top variable or head of the node will be containing the address of the first node 4700. 3 elements are popped out, leaving the only a single element here, that is 3 elements are deleted from the linked list, and now top will be containing the address of only single element, that is the 5000. Display of the nodes one by one, traversing the nodes one by one will be done in a sequential manner, because here we are considering the linear linked list. So, linear linked list is used to represent the stack. So, one by one the elements will be read, the head pointer or the top pointer will be pointing to the topmost element of the stack, one by one the head pointer will be incremented and the elements will be printed out or visited. So, we have seen in today's lecture that what is a stack, what are the applications of the stack, what are the different operations which can be performed on the stack, and the operations can be performed using arrays as well as linked lists. Thank you.